Welcome to solverfy.
In the given problem, we have an electron which is trapped in an infinite potential well. The electron is currently in the first excited state. We know that the ground state is denoted by n equal to 1 and the first excited state is denoted by n equal to 2. The purpose of the calculation is to determine the width L. Okay. We also provided the information regarding the 5 longest wavelengths that the electron can absorb via a photon in order to make transitions. Now the longest of these is lambda A. If you notice, the value of lambda A is equal to 80.78 nanometers. Now I can write a relationship between the energy versus wavelength, and we see that E is equal to C over lambda. So we notice that anything which has a long wavelength will lead to a very small energy. So the longest wavelength, lambda A, corresponds to the lowest energy. So this corresponds to lowest energy. Accordingly, we can say that the lowest amount of energy that the electron can absorb to make a transition is given by lambda A, and let's call it EA. However, we know that just above N2 we have another level which is N3. So in that case, the lowest amount of energy which is required should be equal to the difference between N equal to 2 to N equal to 3, because the electron can directly jump from N equal to 2 to N equal to 3 by absorbing a certain amount of energy, and that will be the minimum energy that it can absorb. The electron can also jump to N equal to probably 4. As we see that the energy required will be greater than what is needed for n equal to 3. So EA should actually correspond to the energy difference between E3 minus E2. Now the energy of an electron in an infinite potential well is given as En is equal to n square h square over 8 ml square. And since EA is equal to, in this case, C over lambda A, I can write the whole thing as C over lambda A. This is my A is equal to h square over 8 m. M is the mass of the electron, so let me write a small e. L square, this is the width we need to find out. And 3 square is 9 and 2 square is 4. So now we know all the factors except for L. So in that case, we can write L as equal to root over of lambda h into 9 minus 4 over 8 m. Now I can do one thing. I can multiply this with a c and this again with a, because we need to understand that there is an L on this side, the lambda goes here, c comes in the denominator, so we will not have a c here. Once you plug in all the numbers and convert this into EVs, we get 0.350 nanometers. So you need to ensure that all the variables or all the constants have the respective units, and we get L is equal to 0.350 nanometer, which is equal to 350 picometers.